on single replacement with both metals and non-metals. So for a single replacement, if the single element is a metal, then first of all, we gotta label these. One will always be a metal and the other will always be a non-metal. However, in the future, when we go into more advanced chemistry, it may not always be metal and non-metal, but at a grade 10 level, it's going to be metal and non-metal. So when A is metal, it will, when we do single replacement, it will literally just replace the metal. In the future, in grade 11, we will go into why it does because of like its reactivity, but we don't need to know about that now. So if A replaces B, then our equation would be something like AC plus B, right? Because A just replaced B right here, so that would be the product. And for a single replacement with a non-metal, then if this is not a non-metal, then it will literally just replace the non-metal. Yeah, it's really simple, and we will have C plus AB, because now A and B are connected to each other. All right? So let's try. 1 is single replacement with a metal, and 2 is with the non-metal. All right, let's get into it. So, as I said before, and as well the sheet says before, when it is a metal, it is A plus BC, right? Which will equal AC plus B, right? Magnesium is a metal. So is sodium. So this is A, this is B, this is C. So what we will do is we will swap A and B. So what are we going to get? We are going to get NaCl and magnesium. Now that we have all of this, we can start balancing our equations. So to balance our equations, it's just like everything else. Oh, but however, there is something we have to remember to do before balancing. This new compound, we will check how many what the charge is, and then make sure that the charge is balanced, or like we don't have to add anything else. So like make sure they do actually cancel out, so there's no subscript. So sodium has 1, chlorine has -1. And when you swap them, it turns into Na1Cl1, which means they just cancel out. They're invisible, like I said last video. So what we will get is, just NaCl. So that's just confirming, because there are instances where we will have to add, for example, brackets to include another subscript. All right, now let's get into balancing. So on our left side, we have 1 sodium and 1 magnesium and 2 chlorines. We have 1 sodium on the right, 1 chlorine, and 1 magnesium. Now to balance this, we're going to have 2 chlorines on the right side. So we do that. But we will now have 2 sodiums as well. So what do? We added 2 with the sodium. So now sodium will also have 2. And now everything's balanced because we have 2 sodiums, we have 2 chlorines, and we have 1 magnesium on each side. Now I'm going to move everything a bit so we have more space to work. So in this situation, oxygen is a non-metal. Magnesium is a metal, as said before. and fluorine is a nonmetal. So this time we will be replacing nonmetals, as A is a nonmetal. So the equation is A plus BC, but this time we're doing we're replacing A for C, so it's gonna be, that's not a B. Why did I write B? We're replacing A and C, A with C, so we're gonna have C plus AB, and so we just like do that, I guess. So what is A? A is oxygen, and then B is magnesium. So the reason I'm using M is the metal always goes first. So I almost wrote oxygen first, but it's not. So it's MO. So magnesium and oxygen. And then we have fluorine by itself. But as we learned previously, fluorine is one of the 7 diatomic elements right there. So it likes to exist with the buddy. All right. So we're going to have 2 fluorines. But now we can check the charges of magnesium. Oh, I forgot the G. Magnesium and oxygen. So magnesium on the periodic table has a charge of 2. Oxygen has a charge of -2 or 2 minus, and then that way we have Mg2O2, which is just MgO. All right. We can erase that to make it more clear. So what do we have? Fluorine 2, magnesium 1 on the left, and 1 over here. Oxygen we have 1, but over here oxygen we have 2. So to make the oxygen over here 2, we just add a 2, but this will make magnesium 2 as well. But because of that, we will have to make the magnesium here 2 as well. But that would give us 4 fluorines, so we just add another 2. And there we have it. We have the balanced equation. Yeah, it's pretty simple. And now we can move on to some examples. Now, one quick note is for our teacher that I'm making this tutorial for, she doesn't mind what order we place these 2 in, but I'm pretty sure standardly it's this first, like the larger, like the, I guess you can say, the compound first before the single element, but our teacher does not mind, so you can write it either way. And for some examples, I'm going to do number 4 as an example, but if anyone has any other questions, you can comment or send me a text if you know me. So to start, I identified the A, B, and C, so the metals and nonmetals. So iron is identified as a metal, copper over here is also a metal, and SO4 is a nonmetal. So on our test, like the people I'm making this tutorial for, we will get the periodic table and a list of common compounds and their charges. So you don't have to worry about memorizing this for now, although you probably will memorize it after using it a lot of times. So this time I checked on Google. SO4 has a charge of -2. On the test, just look for it on the sheet. It's going to be there. So SO4, so the charge is -2. We will be using that later on in this question. So now that we've identified which are metal and which are non-metal, we can label them as A, B, C. And because A is a metal, our equation will equal AC plus B, right? Because A replaces the B, all right? So we can get started. Just pretend this doesn't exist. I can explain the question. Because if I just did it as the question went, it'd be too easy because I think everyone can label. And this is a perfect opportunity to explain a point. All right, so what we will have is we will have iron and what's this called? I don't want to say something random. It's called sulfate. So we will have iron and sulfate. We'll have iron and sulfate. The reason I'm writing them far apart is because we will have more things to write in between them, which I'll explain in a second. And then what is left over is our copper. So we can write our little copper right here. Now, this is where the crisscross check method comes into use. Why did I write SU? It's not SU, it's SO. SO. So this is where our cross-check method comes into use. So iron has a charge of, well, it's right there, has a charge of 3 or 2. So our teacher that I'm making this tutorial for, she wants us to use the lower charge. So 3 and 2, well, the lower is 2. But if you're just watching this tutorial because you need help, you gotta ask your teacher which one he or she wants. Or if they don't specify, just use both. Sometimes they will specify, like after iron, they will write like brackets like 2 or like bracket 3 to tell you which one to use. But yeah, for our teacher, she's asking for us to use the lower numbers, so we will use 2. And as I said before, sulfate has a charge of -2. But sulfate is this like compound here, right? So it will keep the 4 actually. So in this case, we will actually like swap these, right? The charges, and we will get Fe2 and SO4 2. Now you might be wondering why sulfate, so this thing over here, keeps the 4. Well, it's because 4 is literally a part of it. Without the 4, it's not sulfate. So when we write it, it's a part of it. Now, our teacher wants us to simplify this when we solve it. So the 2's would cancel out to be iron sulfate. We wouldn't really need the brackets anymore either, or parentheses, whatever you call them. Now, I think the reason why in the question it says 2 and 3 is because it used 3. But our teacher wants us to use the 2. And also, if you use the 2, the equation's already balanced. And this question, it says balance. The chemical equation is basically useless if it's already balanced. But as you know, if the iron was 3 in this case, and this is -2, remember? So it would, you would just swap it, and you would put the 3 and 2 on the opposite sides, and you would get this. For our teacher, we want to use the lower one, so it's 2. Unless she specifically says 3. Without that, we always use the lower one, okay? So now we can just balance it, because why not? We solved it, why not balance it, right? If we solved it using the 2, then it would be like this, and these two would cancel out and the equation would already be balanced, but we did not solve it like that. Well, we did solve it like that, but we want to balance the equation for practice. So currently we have SO4, and we have 3 of them over here. So, but yeah, so we just put a 3 here. So we will have 3 copper and 3 SO4. And iron, we have 2, so we just put a 2. And so irons are balanced. Sulfate is balanced. But what is not balanced is the copper. And we have 3 on the left side, so we just put 3 on the right side. And now we have it balanced. And for the next video, I'll probably do double replacement. We haven't learned this yet, but I think understanding it beforehand, before our teacher teaches it, will be beneficial. Thank you.